Good morning, everyone, and welcome to our Unified Iceberg session today at Next, where we will discuss how you can unlock enterprise storage performance on open Iceberg format without sacrificing interoperability. My name is Yuriy Zhovtobryukh, and I am a product manager at Google Cloud Lakehouse team. And today with me, I have my colleague Parth Desai, who will bring the concepts that I will be talking about and our innovations to life through a demo, as well as Mark Kubik, a senior vice president for data and analytics at Global Payments, who will show us how a company that has grown through acquisitions and has a very diverse multi-cloud environment has unified their data through open Lakehouse. Now, if you're building a lakehouse today, chances are that you're using Apache Iceberg. It has gained massive popularity among data teams trying to use multiple engines on a single copy of data for different workloads. Over the past year, we've seen almost 3 times growth of Apache Iceberg data in Google Data Cloud. However, as our customers try to scale the use cases to production, they frequently run into infrastructure limitations. Achieving enterprise-grade price performance on Iceberg requires meticulous table management, optimizing data layout, handling file sizes, handling metadata bloat. Activating all use cases on Iceberg is hard as well. Real-time analytics often requires customers to build bespoke infrastructure. Unstructured data that you might want to use for retrieval augmented generation is still siloed. Replicating operational data stores to Iceberg requires complex ETL pipelines. Finally, inconsistent security models across engines and vendors add to governance hurdles, essentially leaving the data in multiple silos. Luckily, over the years, Google has purpose-built storage infrastructure to solve exactly these challenges, which is powered by our highly scalable, real-time metadata management system and deep vertical integration across query engines, metadata management system, and cloud storage. Last year, we've landed some of these foundational capabilities to Google Lakehouse. We launched managed Iceberg tables in BigQuery, offering fully managed tables experience with open Iceberg format. We launched Iceberg REST catalog for multi-engine interoperability using open standards and libraries. We brought optimizations from BigQuery stack to Iceberg, including BigQuery advanced runtime, partitioning, clustering, history-based optimization to unlock the best price performance. Finally, we introduced some of the advanced analytics features, such as multi-table transactions, change data replication, to manage the Iceberg tables. Still, customers face a problem and the choice. Depending on the ETL architecture, they had to choose between self-managed tables versus fully managed experience. What it practically means is that using open source engines with Iceberg REST catalog for ETL limited BigQuery interoperability and capabilities on the Iceberg tables. We believe that this should not be the case. That's why today I am excited to announce that Iceberg REST catalog tables now offer preview for full write and read interoperability between BigQuery and any Iceberg-compatible engines, including Trino, Spark, and others, so that you enjoy the best of 2 worlds on the single table type. With this public preview, you can create, update, query Iceberg tables with any engine, and enable multi-engine writer use cases on a single tables in a fully interoperable manner. But we do not stop here. In addition to that, you can automate table management to maximize your query price performance out of the box without the operational hassle. Finally, we bring the BigQuery's infrastructure advantage to Iceberg by allowing customers to opt in the tables to use BigQuery streaming infrastructure and advanced ETL capabilities, all in one table. Let's talk more about it. We're continuously trying to improve query price performance. And we normally use industry standard TP-CDS and T-benchmark to see how well we are doing. Through the innovations that we launched last year, like automatic table management, partitioning and clustering, BigQuery advanced runtime, and history-based optimization, we've been able to reduce execution time to X on the benchmark. And now these features are also available not only for BigQuery managed Iceberg tables via the IGA, but also for the Iceberg REST catalog tables. You can also opt in Iceberg REST catalog tables to leverage BigQuery's streaming infrastructure for high throughput streaming ingests and near zero read latency on Iceberg. This is made possible by using our optimized for writes streaming buffer in combination with read-optimized storage and a background job that producing read-optimized files in GCS so that you don't need to take care of things like data compaction, metadata compaction, choosing merge on read or copy on write, etc. Finally, using advanced mode with BigQuery on Iceberg REST catalog tables, you can dramatically simplify your complex extract, transform, load pipelines using multi-statement transactions that allow you to update multiple tables in a single transaction, using change data replication, streaming upserts and deletes from the source system to the Iceberg table, and also do OLTP data replication using data stream. How many of you are still managing substantial data footprint in legacy data lakes by Parquet files? Yeah, that's quite a few hands in the audience. And talking to our customers, what we discovered is that modernizing these from Parquet to Iceberg often requires rewriting the data. And this is computationally expensive, which also translates into cost and takes time. So to make things easier for you, we have launched our UI-based approach for zero-copy Parquet conversion to Iceberg, whereas you can basically add your Parquet files in place to Iceberg tables in a matter of minutes without copying the data, without provisioning any infrastructure since it is serverless, and have the observability and error handling built in. Now it is available for you to try and preview. Well, there's been a lot of innovations, but it's better to show rather than tell. So I'm passing my microphone to Parth to walk us through these capabilities in a live demo.
Thank you, Yuriy. Hi, everyone. My name is Parth. I'm a product manager for Google Cloud, focusing on Iceberg tables and their interoperability with BigQuery. So today, I'll walk you through a demo on how you can build an open, interoperable, and a unified lakehouse on Google Cloud. So for the demo, we'll take a scenario of The Look, a fictional e-commerce company who's looking to modernize their lakehouse on Google Cloud. We'll take two different user personas. On the left, we'll take a data engineer who's more familiar with open source tools like Spark. And on the right, we'll take a data engineer or data scientist who's more familiar working with BigQuery and BigQuery SQL and BigQuery Advanced Analytics in BigQuery. And for the use case, we'll take a customer behavior scenario where they want to analyze some customer behavior around returned products and generate intelligent insights for their business users and executives. How many of you here use Spark? Yeah, so a lot of hands. How many of you use BigQuery? Yeah, I see a lot of hands. And this is the same situation that we run into in organizations where different teams use different platforms or query engines, and they can and oftentimes they have to create these data silos where they have to move the data into their query engine or data platform to analyze it. But with our unified Iceberg offering, you can keep the data where it is, a single copy of data, and all these different teams can now interoperate on the same table. So that's what we'll showcase. We'll showcase how these personas can seamlessly interoperate on a single unified table in a unified catalog and namespace, and with unified governance and security. So for the demo, we utilize a few of our services on Google Cloud Platform. In the middle, you'll see the lakehouse runtime catalog, which was previously called as BigLake, which is an Iceberg REST catalog specification compliant catalog. So this is the control plane wherein you'll create all your tables. These tables will have fine-grained table level access controls, credential vending for unified authentication and authorization across any engine that kind of configures to use this catalog and queries the tables, regardless of whether it's Spark, Trino, or BigQuery. The same unified credential vending and table level access controls will be enforced across these engines. And you can also opt in for automatic storage optimization so that you can run background jobs and manage the storage. On the left, we'll be using the managed service for Apache Spark, previously called as Dataproc. This is a serverless Spark offering, where there's no concept of a cluster, and the Spark user will basically run Spark jobs using this managed service. And on the right, you see BigQuery. I think everyone is familiar with BigQuery, but this is our petabyte scale data platform wherein you can run SQL, advanced analytics functions like AI functions. You can build machine learning models using BigQuery machine learning. You can ingest high amounts of data using high throughput streaming using our Write API. And you can also analyze unstructured data by joining our Iceberg table with unstructured data. And towards the right, you'll see the Gemini agent platform, which was previously called as Vertex AI. So we'll call Gemini to basically analyze our product returns data. And then finally, we'll show how this all can be really simplified for your business users and executives by using a conversation analytics agent on top of your Iceberg data. And all of this is, again, built on the foundation of Google Cloud Storage. So this is our object storage platform, wherein you can ingest large amounts of structured and unstructured data with high durability and availability. So with that, let's go ahead and start with the demo. So I have a pre-recorded demo here. So this is the Iceberg REST catalog. This is the control plane. This is the UI wherein you configure your REST catalog in BigLake, or like Lakehouse Runtime Catalog. You configure your Google Cloud Storage bucket. You pick your bucket where all the Iceberg tables and namespace will be created. And then you choose the authentication type. So you can either choose end users credentials or credential vending. So I have a catalog already created, so we'll just look at that one. So this is my catalog. I have my Google Cloud Storage bucket path in there, and this is a REST catalog URI, which the open source engines can use to connect to this catalog. And then I've configured my credential vending. So that's the authentication mechanism that I'm using. So when you do this, it will generate a service account, and this service account will now get access to the underlying cloud storage bucket, so that your end users don't need access to this bucket. This service account will provide downscope credentials to your end users, regardless of what query engine they use. And then you can see all the namespaces that are already created in this catalog. You can also create a new namespace from the UI. So namespace is just like a file directory within which your tables will be created. So that's the configuration of the catalog. And now we go to the Studio notebook. So for a Spark user, they can use this notebook anywhere. But this is a BigQuery Studio notebook where you can run Spark and BigQuery both in the same notebook. The Spark user will first start an interactive serverless Spark session and also configure Lightning Engine, which will provide 4x performance improvement compared to open source Spark. And then they'll connect to the REST catalog. So the same catalog that we just created will provide that path in here and also configure vended credentials. So now your Spark session is connected to the Iceberg REST catalog. And then we'll start the serverless Spark session. So once this session starts, okay, so it was created, and now you can see the details about this session, like all the different properties that you have configured, Lightning Engine, and other details in here. You can monitor their Spark session. So once that is done, now the Spark user, let's say, wants to start creating tables and namespaces. So first of all, they'll create a namespace. So we'll create a new namespace called Lakehouse in the REST catalog using Spark. So this is open source Spark syntax. And then they'll create a new Iceberg table. So this is, again, open source Iceberg library and creating a partition table and adding a table property to opt in for table management. And now in the same namespace, a BigQuery user can also create a table using BigQuery SQL DDL. So this is net new. This was not possible until today. But now you can create new tables in the same namespace using BigQuery. So let's say your products data sitting in BigQuery. You now create a products table from BigQuery. And then the Spark user, let's say, also wants to create one more table, which will join the previously 2 tables that we created. And then when we do a show table properties in Spark, you'll see all the table properties that were configured, including the Iceberg properties, standard Iceberg properties like snapshot, ID, and so on, and also the GCP properties that we are launching, which will help you to opt in for table management or advanced features in BigQuery. And now when the Spark user does a show tables in the lakehouse namespace, it will see all the tables, including the table that was created by the BigQuery user. And similarly, for the BigQuery user, they'll be able to see this namespace in the BigQuery left navigation panel. Using this lakehouse icon, they are able to discover these namespaces and the tables, and will show the same 3 tables in the BigQuery UI. So here are the 3 tables. They can see the details about the table. So here are some details about this table that was created by the Spark user. The BigQuery user can see the schema and the other details like partition and other properties, and it will say that it's an Iceberg REST catalog table. So now going back to the notebook, so we created the tables. Now the Spark user wants to, let's say, run an ETL pipeline or just ingest some data and hydrate this table. So we'll insert some records into this table from Spark. So this is Spark DML. So we just inserted a few records, and then obviously you can see those records from Spark. But at the same time, the BigQuery user will also be able to see these records in BigQuery with strong read consistency. So this data is available immediately for the BigQuery user. Now, on top of just reads, you can also do BigQuery DML, DDL, and use all the advanced features in BigQuery to do things like feature engineering, which is a common use case in data science where you want to add new columns, add for new features, run some analytics. So this is a use case we'll show for feature engineering where the BigQuery data scientist wants to add a new column on the same table that was created by the Spark user and add features in there. So first we'll do an alter table and add a column on this table from BigQuery, and then we'll run an update command to basically update the descriptions by calling an AI function in Vertex AI and using our latest Gemini models, Gemini 3, to generate description about these products. So again, this was not possible until now. This is net new that you can now write to these tables from BigQuery itself. And then once the data is available, you can read that from BigQuery immediately, obviously, and you can see the descriptions in here. So based on the product name, Gemini was able to generate descriptions for these products. And at the same time, the Spark user can also view these most up-to-date data in Spark with strong read consistency because we commit synchronously to the REST catalog. So this is the read-write interoperability that we're talking about. Now let's take a look at example of an unstructured data analysis. So I have some product images in here on my Google Cloud Storage bucket. So I have a pair of jeans products in here. So I want to analyze this with my Iceberg data. My product data is in Iceberg, but my product images are in an object table in BigQuery. So you can now join your Iceberg table with object tables in BigQuery to generate insights. And here we're getting descriptions based on the product images. So you'll see the descriptions are high fidelity descriptions based on the images of the product. So unstructured data is not natively supported in Iceberg, but with BigQuery, you can now basically take advantage of BigQuery's object ref and unstructured data support to join your Iceberg tables with unstructured data. Then let's take a look at example of a multi-statement transaction. So again, Iceberg itself does not support multi-statement transaction, but with BigQuery, you can now run multi-statement transactions on your open source Iceberg tables. So we'll create a table in advanced mode. We'll first just add some data into this table. It's an order history table. So we just inserted about 180,000 rows in this table from BigQuery. And now we'll create a new table called order history returns. We want to move some data from the order history table to the order history returns table. So for that, we'll again run a multi-statement transaction, which is a multi-table and multi-statement transaction, when we'll update 2 tables, move data from one table to the other table, and then delete the source data from the source table in one single transaction. So again, you can do more with Iceberg by utilizing our BigQuery's infrastructure. And once that is updated, you can see the most up-to-date data in BigQuery and in Spark. So here you see all the return products have been added into the returns table. And then the same table can be read from Spark with strong read consistency. There you go. So now let's take a look at streaming. So again, streaming is really hard to do with Iceberg because of the small files problem. But with BigQuery's high throughput streaming backend, you can use that infrastructure to basically ingest tens of gigabytes of data per second, or that equates to hundreds of thousands of rows, and read that with low latency. So I have a streaming pipeline running on this table in the backend, but you can see the most up-to-date timestamp that are being generated and the most up-to-date rows that are being ingested into this table in here. So again, really powerful capability here with streaming for real-time data. And then here you can also see the count getting updated. So I'm adding about 100,000 rows to this table, but the table itself has more than 140 million rows. But you can see these rows getting updated. So this was all well and good. With notebooks, data engineers and a data scientist can use it. But what if you want to just democratize this data to your business users and your business analysts and your executives? They might not know how to run SQL queries or Spark queries. So for that, we have something called conversational analytics agents built right into BigQuery. So this is our first-party agent. You can build a new agent within BigQuery and expose this using BigQuery Studio or Data Studio or just an API for an end user to use it. So you can create a new agent with a simple UI interface, add the name of your agent, and then you add your sources. So these are the tables that we just created from Iceberg tables that we just created from Spark and BigQuery. You can add those as sources to ground this agent. So I have one agent already created. I'll just take you there. So this is a retail insights agent that I created for the data that we are working with. And I have all my knowledge sources in here. So these are all the Iceberg tables that we created. I've added them as knowledge sources for this agent. You can give some additional instructions to the agent. So if there are some specific field IDs or column IDs that are important or something to ignore, you can give those additional instructions. You can also add some verified queries, and Gemini itself generates some verified queries based on the tables that we just populated. So you can pick a few verified queries that you think are going to be more relevant for the users. And then you can also add your own internal glossary terms. So if you have some internal terms and terminologies, you can also add those to give more context to the agent. And then you can just preview this. So you can just ask me, you can just chat with your data by saying that, hey, show me top products by category. And behind the scenes, it's using the latest Gemini models, and it just looks and feels like you're talking to Gemini Enterprise. So you can save this, and then you can also publish it. So this takes a few seconds, but you can save it, and you can publish it. And there are different options to publish. You can publish it in BigQuery. You can just publish it as an API for a front-end UI that you might have, or you can publish to Gemini Enterprise or Data Studio as well. So I have a conversation already running, so I'll just take you to there. So this is an example of a business analyst or an executive who just wants to drill down on some data. So they might start with, hey, show me a breakdown of top products by category. So it generates these visualizations. It also gives you some additional insights and interesting correlations between the data. And then you might want to dive deeper and say, OK, which categories are returned most? So you see that jeans is one of the categories. And say, so now you want to see, OK, which products within the jeans category are getting returned. And then finally, say that, OK, I actually want to look at these products. Like, why are they getting returned? So say, what do these top 3 jeans products look like? So Gemini, this agent is intelligent enough to actually fetch this data from the cloud storage object where I have stored the images and renders that into this agent workflow. So with this, just with a few seconds and a few questions, we were able to drill deeper into our data and identify like what is the core capability that we're lacking and what is the return data looking like. So just coming back to the architecture, I just want to reiterate what we did. We created tables from both Spark and BigQuery in a unified lakehouse and a catalog. We then ran DML statement and updated the data from both sides, from BigQuery and Spark, and the data was available right away for the users to see with strong read consistency. We ran a lot of advanced analytics functions on top of Iceberg data, which is difficult to do. But with BigQuery's advanced capabilities, we were able to run multi-segment transactions, streaming, BigQuery machine learning models, AI functions, and analyze unstructured data. And finally, we created the conversation analytics agent on top of the Iceberg tables to democratize the data to your end users. So if you're interested and have more questions or want to leave us feedback, then please reach out to us at this email, and we can work with you to get you onboarded on this unified lakehouse offering. This email chain has all the PMs and engineering on it, so we'd love to collaborate with you and understand your use case. But enough talking from us. Now let's hear it from Mark, who will talk how global payments is deploying this at scale and building the open lakehouse. Thank you, everyone.
Thanks, Parth. And thank you all for being here on a Friday late end of your conference. Hope you've enjoyed it. But yeah, Mark Kubik, Global Payments. So we'll start with a little bit about global payments and why this is important for us. We're a company of acquisition, as Yuriy said. I mean, we've been acquiring companies for a long time. We just merged with WorldPay. This is what we've become now. We got data for 6 million merchants across the 175 countries. Unifying data amongst all those is a challenge, and my team takes that on every day. And we've been working with some of this technology, and the announcements these guys have made today have made their life and my life easier. And I'll show you what our path was. And you know, we as Global Payments were large. We process together about $3.7 trillion worth of volume. It's about the GDP of the UK. So we are at scale. This has been our journey. We started way back in 2016, 2017 with BigQuery. We've been with Google on this journey. We launched our Caspian data lake there in 2019. And really what we did for the next 4 years is we expanded that, growing to about 4.5 petabytes, multiple workloads. It was a lakehouse. We had multiple workloads. We satisfied BI, APIs, data files, everything out of there. And then we had more mergers and acquisitions. We added data across time. That became more challenging. You move that data, you got to move it over here, put it there, try to consolidate it. That becomes expensive and time consuming. In 23, 24, we actually presented that open lakehouse architecture. We saw Iceberg coming. My architect at the time saw that coming. He's like, we got to go there. So we started moving when it was BigLake. It was just a thought, really, in my opinion, at Google. We started seeing that, hey, BigQuery can use this Iceberg. They have these managed tables. What can we do with that? What does this look like? So in 2024, our executives, we went on a transformation journey and we funded our next generation of open lakehouse. We called it Tidal. And then now we're enabled sharing with BigLake. BigLake, now it's, you know, Google Lakehouse. And we unified that data in 2025 through sharing, not copying, for the enterprise. We started to do that, and now I'll give you a use case at the end of some near real-time replication. We were able to use the Cross-Cloud Connect and other things. It was BigQuery Omni, but now it's called Cross-Cloud Connect to solve a use case that we had. So let's talk about, you know, that open lakehouse, the things that we needed. You think about our company, you know, we needed a unified data platform. We got a lot of them. We're acquisitions. We get a few. We can't just put them all into one. That takes time. That takes money, investment. How can we unify it? Data, that open format. You had Parquet. Here's Iceberg. It's winning the war of the open format, in my opinion. That's where you see everybody writing to and going there. It allows that data sharing and collaboration without moving it so that we can put it together. You still need the definitions, the glossary and all that, but that technological piece, we're solving that. We're solving that at the base layer. Now, bring your best toy, bring your best tool to it with the Iceberg format. You stick to the diverse workloads, and of course I have to mention AI because you can't be at this conference without mentioning AI, but bring your AI workloads there, you can get there. And then near real-time data, I'll show you that. That's where everybody wants to go. You know, for us, it's fraud. That's a lot of the use cases there, or our customers demand it. They want to set up a terminal and see that they swiped something and see that the data went through and they got it in seconds. So near real-time data becomes, and that open lakehouse architecture with this helps us solve those use cases. If you think about it, you know, 2024, the reason we got here, you may not get there, but we had a transformation opportunity at Global Payments, and we invested in funding our data and AI capabilities, and that really is what launched us. So that's when we really started, you know, focusing on this and starting to convert from BigQuery native to Iceberg format and starting to do that across time. This is the one slide that's fun. GP, we just had fragmented lakes everywhere with the different acquisitions that we had. That data, we had to get it unified, right? And that open lakehouse allowed us to do it. What we had was this. We had built title in Google, in GCP. Our sales organization, they liked Snowflake, and they liked Azure. There were a lot of .NET guys. They loved that. That was sitting over there. WorldPay, we just merged with them. They're in AWS. We had our POS solution in AWS in Aurora out there, and when we had another Zego, it does payments for HOAs and those type of things, and that was in AWS and Snowflake. With that Iceberg format, we were able to take all of these systems, and we have successfully now shared data between all of these at scale today. The minor issue was the catalog sync, and this is really cool where Google came up with a federated catalog now. A little scripting solved that. We had to copy data from one catalog to the other, but that's okay. We could do it on write, and we could make it available between all of those systems. So that was exciting for us. It made my team's life easier, and the announcements that they had were cool because now instead of BigQuery Omni, it's Cross-Cloud Connect. Instead of BigLake, it's Google Lakehouse. All of these things made my life easier. We didn't have to do any workarounds or anything like that. This was really cool. Our CEO came to us in late January, and one of our top priorities was to get an AI assistant bot out there for our POS solution. That is one of our places where we make money. It's a good revenue driver, and you gotta have those capabilities that people want out there. And he says, okay, I need this, but I need it by the end of March. Okay, where's the data? Data need to be near real time. In that previous diagram I showed you, it was sitting over in AWS. What did we do? Used Glue, wrote it to an S3 bucket to Iceberg. That's where it was, so now it's in S3. We used BigQuery Omni, now Cross-Cloud Connect. We sync that data back over to our Google infrastructure where our AI framework is running. The team got that set up, and now we did the data prep in BigQuery for that assistant. The project was complete in less than 2.5 months. It did go to pilot, and they're going to roll that out to National Restaurant Association next month. But that was cool because I didn't have to move the data, didn't have to build new pipelines. I could sit it over there in AWS, get it over in Google, use the nifty AI capabilities over there, and deliver a project. Now I saw, with AI, I could probably even do those pipelines quicker with some of the things I've seen here at this conference. But the point I'm trying to make is this is reality. You can do it. You can reduce time to market. You reduce your data footprint and make it easier to share data across your company if you're like us, where you don't have one unified platform across the world. But this is my own quote, but we've been working around this stuff for the last 2.5 years at Global Payments. It works. We had some tweaks to do here and there, but now with all these announcements, what my point is, it's made it easier. Google has come with us on the journey. They've announced some things that they've put in place here at this conference that honestly for you guys, I think it'd make it easier for you to unite your data if you have the same problem we have, data everywhere, but it makes it easier to bring workloads to that data.